All right, in this video, we're going to look at Cauchy's integral formula number 2. So in an earlier video, we already established Cauchy's integral formula number 1. So this one, we're going to abbreviate it CIF2. So it's going to be CIF2, the one we derived earlier. We called CIF1. Okay, so this one states that let f be an analytic function inside and on a simple contour C, and let z not be any point inside C, as exactly the same as was stated in CIF1. Then in this case, the integral of this function is going to be equal to 2 pi I times the nth order derivative of f evaluated at z naught divided by n factorial. Okay, so let's just look at the derivation of this. So we're going to start with CIF1, which is stated here. Then what we're going to do is we're going to treat z naught as a variable and differentiate with respect to z naught. So differentiate with respect to z naught. So on the left hand side, we're going to have partial z naught of the integral of f of z divided by z naught dz. We're using partial on the left hand side because this involves z and z naught, since we're treating z naught as a variable. So this is depending on two variables, so that's why we're using the partial derivative notation. This side, z naught appears here, so differentiate this with respect to z naught. That's simply going to be f prime at z naught. Okay. So here, if we, because that's the term that's got z naught. So if you write z minus z naught to the power -1, differentiate this now with respect to z naught, we're going to multiply by -1, subtract 1, then multiply by -1. So there's going to be 1 over z minus z naught squared. So that means what we're going to have on the left hand side is the integral of f of z divided by z minus z naught squared dz is equal to 2 pi I f prime of z naught. Okay, then if we differentiate again with respect to z naught, differentiate again with respect to z naught, this time we're going to have to multiply by 2 here. So the left hand side is going to be 2 times f of z divided by z minus z naught cubed dz. On the right hand side, this is just going to be the second order derivative of z naught. I am going to move these two to the other side, so we can write this as f of z over z minus z naught cubed dz is equals to 2 pi I f double prime of z naught divided by 2. Now if we differentiate this again with respect to z naught, we're now going to have 2 times 3 there. Okay, so differentiate again with respect to z naught. Alright, so differentiating again with respect to z0 here is going to give us 2 times 3 times f of z divided by z minus z0 to the power 4 dz. Right hand side, we are now going to have the third order derivative of f. Now 2 times 3 is 3 factorial, so moving this to the right hand side is going to give us a z minus z0 to the power 4 dz is equals to 2 pi I all over 3 factorial. If we do this n times, then on the left hand side we're going to have f of z over z minus z0 to the power n plus 1. So this is what happened. After 3 times this becomes 4. After n times it's going to be n plus 1. And then this side we're going to have 2 pi I, and then we're going to have the nth order derivative at z0 divided by n factorial. So this is the second version of Cauchys integral theorem formula, I mean. So let's now look at some examples. Okay, in this first example, we are going to be integrating this function around the contour. In the first instance, z minus 2, mod z minus 2 equals to 2. In the second instance, mod z plus 2 equals to 2. So let's see. So for starters, the singularities of this function are going to be when z is equals to negative 1. So integrand is singular at z equals to negative 1. Now let's make a little sketch. So z is negative 1. It's going to be somewhere there. Now in part 1, the contour is z minus 2 is equals to 2, mod z minus 2. So this is going to be a circle centered at 2. This is going to be somewhere here. Radius 2. So that's going to be the contour C in part 1. Now, as you can see, none of the singularity is not inside that contour. So that tells us that the integral is just going to be 0 by Cauchys integral theorem, because the function is analytic everywhere here. So then I is just going to be equal to 0 because the integrand is analytic everywhere inside C. Then in the second instance, we have got z plus 2, mod z plus 2 is equals to 2. So this time we got a circle centered at negative 2. So it's going to be somewhere there. And then the radius of this circle is 2. So this time the circle is going to be is going to contain the singular point z equals to -1, which is this one here. So our Cauchys integral formula part 2 is going to be applicable. Just going to, okay, maybe let me write it here. So that one says, let's just off this here, says the integral f of z minus z naught to the power n plus 1 dz is 2 pi I, the nth order derivative of z naught over n factorial. So the first thing we're going to note is that for this problem, n plus 1 is 2, so that tells us that n is 1, and then the singularity is z naught, so sorry, is -1, so z naught is going to be -1, and then f is just going to be the numerator of this function here, so that one there. So for part 2, f of z is z minus e to the minus I pi z. Okay, if n is 1, we are going to have to differentiate f once. So let's do that there. So f prime of z is going to be 1 plus I pi e to the minus I pi z. So the integral is going to be 2 pi I f prime of z naught. So we simply need to plug in z equals to -1 there, because we said our z naught is -1, and then we are good. So if we plug in -1 there, we're going to have 1 plus I pi e to the I pi, because we plug in -1 there, that's just going to be I pi. So there's going to be 2 pi I 1 minus I pi, because e to the I pi is -1, and then that we can leave in that form. So that is part A. This is part B, so see how part B is going to work out. So in part B, we have integral of z to the power 4 plus hyperbolic sine pi z over 2z minus I to the power of 3. Now again, if we compare this with the Cauchys integral formula, the second one, 2 pi I we can see that in this case n plus 1 is 3, so that means n is going to be 2. And then for the singularity for z naught, we're going to have to take this and equate it to 0. If we do that, we're going to get z naught is equals to I over 2. However, there is a slight issue. The coefficient of z here is 2, whereas the coefficient of z there is 1. So so we're going to have to deal with that. Okay, so what we're going to need to do here is to factor out the 2. So we're going to have the integral of z to the power 4 plus hyperbolic sine pi z. Then we're going to factor out 2. This is to the power 3 dz. Then the contour here is just the unit circle. If you take out the 2 outside the square brackets, it's going to be 2 cubed. So mod z equals to 1. It's going to be z to the power 4 pi z all over z minus I over 2 cubed. This is now in the form which is given in the Cauchys integral formula 2, where f of z is equal to z to the power 4 plus hyperbolic sine pi z. Now since n is equal to 2, we're going to need to differentiate f twice. So first order derivative is going to be 4z cubed plus pi hyperbolic sine pi z. Second order derivative is going to be 12z squared plus pi squared hyperbolic sine pi z. So if we call this thing I, so I is going to be 1 over 8, which is this 1 over 8 here, and then 2 pi I from the Cauchys integral formula. Then it's going to be f double prime of z naught over 2 factorial. Okay, so it's going to be 1 over 16, 2 and 8. Okay, let's cancel these 2 into 2 pi I. So if we plug in I over 2 here, so that's going to be 12 I over 2 squared, going to be pi squared hyperbolic sine pi I over 2. It's going to be pi I over 16. I over 2 squared, this is going to be 4. 12 divided by 4 is going to be 3. So that's going to be negative 3. And then hyperbolic sine of I theta is I sine of theta. Going to be sine pi over 2. Sine pi over 2 is 1. So this is pi I over 16. In 2 is going to be I pi minus 3. Actually that's not going to be 16 because we cancelled that 2, this 2 and this 2, so that's just going to be 8 here, 8 there, and 8 there. Okay, now we are going to give you an opportunity to have a go at part C. So there is part C there. You just want to pause the video and go through this. Yeah, incidentally, we didn't do the plot of the so the singularity of this function is at I over 2. There's I over 2, and the contour is z mod z equals to 1, which is a circle of unit radius. So that finishes that up. Okay, so if you'd like to have a go at C, so there is C. Just pause the video and then you can compare with our answers later. Alright, for this function, the singularity is z equals to 0. So you can write this as z minus 0 all cubed. So 0 is located at the origin, that's where the singularity is. Our contour is the unit circle. So our z naught is going to be equal to 0. N plus 1 is 3, so n is 2. And then f of z is the numerator, e to the iz, because z. We differentiate this once, that's what we get. And then differentiate it again, that's what we're going to get. So this finally gives us negative e to the iz into 2 cos z plus 2i sine z. Then the integral by the formula is going to be 2 pi I f double prime at z naught over 2. Now these 2 and these 2 cancels out. If we plug in z equals to 0 here, it's going to be that. This is going to give us 1. This is going to give us 0. So this works out to minus 2 pi I.